All right. Hello, everybody. I want to welcome to our PolarConnect event. Today we're going to be talking with PolarTREC teacher Dave Jones and his researcher that he worked with through the PolarTREC program, Mike DeGrandpre. And today is November 1st. Hard to believe it's November already, 2017. We have a lot to cover about this amazing research project that they did up in the Arctic Ocean, up in the Beaufort Sea. So we'll get started with their presentation in a moment. Today's PolarConnect event is hosted by the Arctic Research Consortium of the United States and myself, Janet Warburton, and I'm assisted with Judy Fonstock. Both of us work for ARCIS and work on the PolarTREC program. Before we get started, there's a few things if you've joined us virtually that you need to know about, and that's mostly how to use this platform. It's pretty easy. You can see Dave and Mike up in the webcam. So there they are, looking very anxious and ready to start. A list of attendees and an area where you can type in your questions and introduce yourself, which is actually the next piece of this presentation. Just let us know who you are, where you are, and if you have any students or others with you in the chat area. For those of you that have joined by phone, there is a PDF that we can send you of the presentation, or you can log on and follow along visually and talk through the phone. So just let us know what your preference is there. So the next slide is about the PolarTREC program, and this program is designed to place teachers like Dave with researchers like Mike out in the field, and it's been around since 2004. We have been primarily funded by the National Science Foundation over the years, and the whole program is run by a nonprofit Arctic Research Consortium of the United States, ARCIS for short, and we are based in Fairbanks, Alaska, with staff throughout the United States. And we work with researchers like Mike on a variety of different issues, and PolarTREC is just one of our many programs that we're happy to host. If you have questions, please use the chat box to do that, and of course, at the end, we'll also open up the mics and the phones so you can ask your questions live. With that, I'm going to turn it over to Dave and Mike, and they're on their opening slide here. We're having battles of the arrows, but I think I'll turn it over to Dave. You can do whatever you want now, Dave. Okay. Go ahead.
I'm just going to go quickly back to that opening slide. So we were on a cruise, basically the 15th year of the Joint Ocean Ice Studies, or JOIS, for the year 2017. And it was on the CCGS Louis St-Laurent, which is a Canadian icebreaker, came out of St. John's, Newfoundland. And now we'll skip back to this. So two main parts of this. One is the Arctic Observing Network, or the AON, and then the other is the Beaufort Gyre Observing System, or the BGOS. And Mike's research is basically intertwined in both of those. He focuses on carbon dioxide and pH studies in the Arctic Ocean. So our travels started in Montana. So here, via Salt Lake, we went to Yellowknife, spent an extra day in Yellowknife, and then eventually flew out to Cambridge Bay, which is in Nunavut, Canada, which is one of the territories. There's the plane, reflection. And then we were picked up there that day and flown out to the ship via the helicopter. And was home for the next 4 weeks. Our proposed course basically went counterclockwise, so we started over here where the arrow is, and then worked our way around and came back down, and then finished up like that.
Can you see the arrow? Oh, there you go.
Oh, there's an arrow. Is that my arrow or your arrow?
That's your arrow. That's my arrow. You can grab the green arrow up at the top and drag it to wherever you want to, okay?
we started here and worked our way around this direction like this and then back. Okay. And that was proposed. Just a little background. So the Arctic ice extent has been on a downward trend over the last 20 years and really started to pick up in 2007. We are this line here, the blue line, whoops, the blue line right there. And the lowest ice extent was in 2012, which was the year you were on, right?
Yeah, that was the first year we went out there.
Right. Yeah. So we were kind of in the thick of things in terms of lows, but definitely not up here in the median.
So that ice minimum occurs around middle of September every year. That's what that plot was showing.
It's just a kind of a photograph of everybody involved. The science crew is this group over here, and yours truly are down here in the bottom, which means we were probably just there. And then here is the crew that was on the ship, and this is the captain up here, and this was the chief science officer over here. Yeah. So first thing that happens on this cruise, and is one of the main projects, is what's known as the Ctd Rosette casts. These happen essentially every day and happen 24 hours a day, 7 days a week. Lots of data being collected on temperature, salinity, pressure, chlorophyll, various nutrients. And then there are a series of Niskin bottles, they're known as, that can be opened remotely at various depths to collect water samples. And this is just a picture. This guy right here is what a typical Ctd Rosette looks like. It's being hung over the side of the ship, being prepped to be lowered. And it's a very coordinated effort. You've got the crew that runs the apparatus coming off of the ship deck. You've got the crew itself actually operating things from the bridge, kind of keeping things going. And again, it's something that happens nighttime, snowing, raining, whatever. And this is just a nice photograph of the Rosette coming back to the surface. Rosette has a number of samples that are taken, but I think there's 15 of them there, that cover a wide range of parameters, everything from dissolved oxygen to various isotopes of specified elements. All of it's going after various aspects of the Beaufort Gyre, everything from what sorts of things are happening in the ecology all the way out to what sorts of pollutants are actually there. The second thing that happens routinely is what's known as bongo net casts. A bongo net is just a large net that looks like a bongo drum, and they are dropped to usually a depth of no more than 1,000 meters and then brought up, and they trap various zooplankton, which are then analyzed later and characterized. Okay, then there's the ice operations. So ice operations have to happen on the ice, and in order to get to the ice, you have to go through the ice. We eventually wound up, I think, at about 81 degrees north to get into some ice that was usable. The ice tether profilers, or ITPs, are actually deployed and left in situation and not actually ever recovered unless they are just so happen to run into them. And they transmit the data that they collect via satellite back to the lab in Woods Hole. And then there's on-the-ground actual characterization studies or surveys of the ice. And that's done while the ITP is actually being deployed. So you got to find some ice that's useful. This type of ice here is what they call pancake ice. It's pretty thin. It's nothing that you could actually deploy anything on. So ships got to roam around and actually find some stuff. And eventually the ship stops after many hours of crunching through it, and the gangway is deployed. In our case, it was the gangway instead of being flown. And of course, the first guy off the boat is the man with the gun, and that's because there are polar bears. And this is actually a photograph that Mike took of a female polar bear and her two cubs, which was about what was that? About 400 yards.
It wasn't quite that far.
Maybe 300 yards off the starboard side of the ship, and we got off the port side. But you got to have the man with the gun out there just in case. And here's the ship just parked in situation with the ice surveys being done. This gives you just kind of a quick look at what the profiler looks like. So you've got a buoy at the top, and come back, a buoy at the top here, and then this is basically a piece of protective material that protects the cable running through the ice, and then you've got a long cable that stretches about 800 meters down, and this piece right here runs up and down the cable and surveys or takes measurements on temperature and salinity and oxygen and all sorts of other parameters.
In the past, we've put CO2 and pH sensors on that too, right there under the ice.
Just right here?
Right in there.
Yeah, yeah. Do you ever get those back?
No. We'd like to.
Okay, and then the ITP being deployed, you got to scrape a platform area. You got to auger a hole in, and then set up a little A-frame. You can't really see that down here, but they set up not an A-frame, a tripod to do all the lowering. And when you're lowering 800 meters of cable, that takes a fair amount of time. And then eventually things are all strung together, and this is what's left behind on the ice. And we got the chance to see pretty rare a full sundog, which was pretty fantastic. Evening. Go. Okay, mooring operations have to happen in the open ocean. It's basically about a 2-day operation where first day there's a recovery of the mooring and second day is the redeployment. And they are seafloor anchored buoys that have a bunch of associated instrumentation on them. So a mooring, quite a big piece of equipment. It's got an anchor at the bottom. It's about 4,000 pounds. It's got about 2.5 miles worth of cable stretching to the surface, and then a pretty large float on top here. And in here is where all of the instrumentation is put. Were you going to say something?
Oh, no.
Okay.
Go ahead.
One thing that they have to also make sure of is a release mechanism, which is down at the bottom, and those are activated remotely when it's time to actually recover it. And so those release, they leave the weight behind, and the buoy floats to the top. And the first thing you have to do is capture it. So the man in the basket goes out, gets a hook on to the buoy, and that's up here. And then they manage to bring it up. And here is one of the paired Sammys that Mike had out there for a year. All kinds of questions there.
Yeah. We'll take these questions later. Is that correct?
I think it is.
Yes, anytime that you're wanting to do them, it's all right. If you see something you can address along the way, feel free to address it.
Okay. Well, that's the face of a happy researcher, because he's got data being downloaded, and data is a gold mine out there because you don't get very many opportunities. Do you?
Things always don't work either, so can't take it for granted.
Right. So Mike's first data set being happily downloaded. Okay. And just a little side on what a SAMmy is. It stands for a submersible autonomous moored instrument. And Mike's measure and logs pH and carbon dioxide levels in marine and freshwater environments, and can be deployed for over 12 months, depending on how they're set up. And this is what Mike has spent a lot of his career working on, developing them and utilizing them. And then they are actually produced now by a small company in Missoula called Sunburst Sensors, which won, was it last year or 2 years ago?
It's a couple years now. So
Yeah.
The X Prize, so that's this thing you see, this silver object behind my head here with the blue swirl on top. We won a competition to develop a affordable and accurate pH sensor. It was sponsored by Wendy Schmidt, who's the Google owner, previous Google owner, and her husband. So anyway, that was a big deal at the time, a couple of years ago. But the SAMMYs, I'll just quickly say that SAMMYs work by using pH indicators and light. So if you shine light through a pH indicator, you can determine the pH of that solution. So they're very simple devices.
Basically what we do in high school chemistry almost. So it's real straightforward stuff, but it has a real, just bomb-proof, and they just get amazing data sets. All right, day 2 involves then deployment. So again, it's a coordinated effort between the bridge and the folks on deck. And basically the weights go in, and then 2.5 miles worth of cable, including some buoys are dropped in, and then the various sensors. And then finally, the surface buoy, which actually ends up about 30 meters below the surface, is let loose, and in a gush of foam and bubbles, it disappears until the following year. And just a nice photograph of one of the deck hands, silhouetted in the light there. Okay, so when all was said and done, when all was said and done, our course actually ended up being a little bit different. We headed out and did pretty much what was planned, but then ended up way north, up around 81 degrees north. And this is where the first ice tethered profiler was cut loose. The second one was here. And then the third one, it actually ended up not being in ice proper, but in water that was starting to freeze up. And today it's probably frozen in place. And then from there, we headed south. We ended up having to do a mooring pickup, and then ended up going to Barrow, Alaska down here to do some side work that involved picking up some equipment. Came back and then headed for this mooring over here. Ended up doing some kind of side trips while the seas calmed. Eventually headed down and did what they call the MK line, which stands for the Mackenzie River line, which is a sampling line, and then ended up coming back and finishing at Kugluktuk, which is over here. So that was 4 weeks right there. And one kind of neat thing is we got to pass just north of the, damn it.
Mackenzie?
No, not the northern range. The, help me out,
Brooks
Janet.
Range,
Brooks
yeah.
Range, yeah. And got kind of amazing photographs of the Brooks Range from the north, which was kind of foreign because you would expect to be able to see them from the south, but not the north. That was kind of fun. All right, so just a quick summary of what's been learned in 15 years of this. First and foremost, the liquid fresh water in the Beaufort has increased steadily. 2016 was the absolute max, and that was 6,500 cubic kilometers over the 1950s through the 80s. The IPE's depth and coverage has also decreased, while the open water fraction has increased. And then the other piece is that ocean acidification, which is what Mike is keyed in on, at the surface has increased, which means there's a pH decrease. And this is seen through a variety of ways, but one of the ways is we see a decrease in calcium carbonate in the form of aragonite, and that's been seen since 2008. It's also been found that the Beaufort Jar deep water is undersaturated in calcium carbonate, which suggests that there's ocean acidification going on there. And all this coincides with reduced sea ice extent, sea ice melt, increased sea ice melt, and corresponding anthropogenic carbon dioxide.
Add a little to that. So we've been going there since 2012, and what we're finding is that as each year the CO2 levels in the sea surface of the Arctic Ocean are correlated with the extent of ice coverage. So you can imagine as the ice comes off the Arctic Ocean, it exposes that surface water to atmospheric CO2 levels that are much higher than they used to be because of anthropogenic CO2 from fossil fuel combustion. And so the ocean's taking up that CO2 and increasing the CO2 levels, and it's well correlated with the ice extent. So we're the first to really document that very clearly.
So he was asking what anthropogenic carbon dioxide is, and that's anthro is human sourced carbon dioxide. So it basically comes back to the burning of fossil fuels, where carbon dioxide is actually coming from. And a final nice shot we got, or I got rather, of the ship. This is at Kudluktuk, so the waters was still, this was October 3rd, was still open, and a little rain cloud came through and put a really pretty rainbow right across the bow of the ship, and I managed to get a shot of that. And that's what I have.
I would add that I hope you can see that we've almost made an oceanographer out of Dave. So.
I know, I'm impressed. He talks like a scientist too. Wow.
I got the bug,
all
that's
right.
for
sure. Very good. All right. Well, there was a lot of questions by me and the audience as well, and Judy. So I'll just kind of go back to the top, and we can leave this picture here, or you can reference one if you need to, and just pull it up as we go along. But so the first one was how many cruises? So you've been doing this a long time. So the question is, how many cruises do you do each year that are related to this science?
We just do this one cruise every year for the last 5 years or 6 years. We do other cruises in other ocean regions. We were in Bermuda doing some small boat work with pH and CO2 sensors on a coral reef this summer. But this is the only time of the year that ship's up there in that region. And the U.S. has one Coast Guard icebreaker as well, and it's operating up there around that same time. But ultimately, there's very little availability of icebreakers to do work up there at any other time of the year.
Okay. That kind of relates to the question that just came up about, are you always on a Canadian research vessel?
This particular Beaufort Gyre Observing System program is sponsored by the U.S. government or paid for by the U.S. government, and it's always on this same Canadian icebreaker, yeah.
Okay.
It's done in coordination. Sorry, go ahead. It's not done in coordination with a Canadian group, the DFO, which is the Department of Oceans and Fisheries, and their Institute of Ocean Sciences. So it's kind of a 50-50 mix of Canadian researchers and American researchers. And then there's actually a couple Japanese and one Chinese, is it? And then what else?
Sometimes there are Europeans on this cruise, but not this time.
Okay. I think that kind of goes to the next question was, are the crews always this big? I think that was that picture you had of your crew, both the Coast Guard and the science team. Are they always about that size?
As far as I know, yes.
Yeah, I think we had some extra cadets on this one with the Coast Guard cadets. There were 4 or 5 or 6 guys. But yeah, so there were a few extra. The science staff was a little larger than usual. It's more, I think there's 28 or so, but they're more like, typically more like 20. The lab space, even though that's a really big ship, the lab space is fairly limited on that ship. And so 28 was, we pretty much filled all of the lab space up.
All right. Yeah. Quite the crew. Okay. How many rosettes are in one CTD?
Yeah, so the whole thing is known as a CTD Rosette. So, and the name Rosette just comes from the kind of flower shape that it has. The little gray pieces are the bottles that can be remotely opened, and then there's various instruments. So you see a little instrument pack down here. There's an instrument pack that sits on the top as well, and those are designed to measure various parameters. CTD stands for conductivity, temperature, and depth. And so those are measured always, and then other aspects are measured as well. And yeah.
Okay. Deborah says that she saw microplastics were on the last slide of materials sampled. Curious whether much of the microplastic is showing up in the Arctic Ocean at this time.
I gotta say that's something I don't know. From what I understand, this is one of the. Correct me if I'm wrong about this, but I think this is one of the first few times they've actually done that kind of sampling, and it just sounded like they were working some of the the techniques out, basically.
Yeah, I don't know if they've been detecting it. I'm assuming that they have been. I think it's pervasive.
Right.
Yeah, I don't have the source of this yet, but there's a woman I know that does marine debris projects around the whole Arctic coast, and yes, they have seen microplastics showing up in pretty much all of the oceans in the world, and I think the really newest research that I've seen is that microplastics are showing up on the underside of the ice as well, not just in the water or at deep depths, but showing up under the ice as well.
They did take some ice samples for microplastics.
Yeah, yeah.
They take those samples back to land, so you don't know what they're finding out.
Yeah.
Hi, Robin Carey and Jim Clapp.
All right. Yes, good. Thank you for joining. If you are just joining us, feel free to type in questions, and then also you can ask your questions live. There's not very many people, so feel free to let us know that you want to just turn on your microphone and just interrupt and ask your question. So Judy was asking, what is in the glass jar? I don't have that picture up. A shrimp. What is the largest organism that you collected?
Yeah, that was a small shrimp. It's probably 1.5 inches, and that really is the largest that they had that I saw. There's a couple little worm-like organisms here, but most of them are pretty small. They're maybe 0.5 centimeter to 1 centimeter in length, with quite a bit of it actually being much smaller than that. But these little guys here that you can see, these kind of orange pieces, are they're probably on the order of about 1 centimeter long.
It's a really unproductive region of the ocean there. There's not much fish swimming around.
Although I got to say, one day as we were going through the ice, I saw this fish on the ice flapping around and had obviously been thrown up as we went past somehow. And I thought to myself, I wonder if that fish is actually going to ever survive.
Unusual.
Yeah. Didn't get a picture of that, though.
Yeah.
That would have been a great picture.
It would have been a good picture. And then obviously you are not the cruise that's all fishing off the back of the boat for your weekly dinner or anything, or nightly dinner.
No.
No.
The water is so clear and so blue that you once you kind of realize that, the reason it's so blue and clear is there's not much nutrients there, and therefore there's not much biological activity going on there either.
All right, that answers Judy's question, which was, why is it so unproductive?
Yeah.
Okay, let's see. The next one is about the tethered profiler. How many sensors can you put on a profiler? Let's see where to go.
Yeah.
I'm getting there. I don't know where I'm going here on this thing. No.
Keep going.
Somewhere there. Am I going up, back? Go, if you know where it is. There you go. I don't know. There.
Yeah.
So how many sensors can you put on there?
On this, let's see, where's the pointer?
I mean, can you just load it up, or is it just, I don't know how many, you have just one sensor, or I don't know, maybe.
Yeah, there's a number of sensors. So this kind of lists what are actually on the ones that were deployed this year. So you've got temperature probe, you have salinity and oxygen. I don't know what now is. Fluorometer. Do you know what OBS is?
Optical backscatter. Yeah. So that's gives a sense of how many particulates are in the water.
Yeah. And then they had a current probe on them also that detects, the direction that the water is flowing with respect to the profiler.
But that gray tube there goes up and down. It goes from about 800 meters at the bottom to about 9 meters below the ice at the surface, and measures most of those parameters all through the water column.
And that's
so how frequently, or how does it go up and down? Like, is it just timed up and down, or
it's programmed, and there's a little motor that basically runs a small wheel that basically just grabs the wire, and if it's rotating one direction, it goes down. If it's rotating the opposite direction, it goes up. And so it's programmed to do between 2 and 4 profiles per day. And it can do more, or it can do less, but that's what they had it set at. And it just runs up and down the wire. And I don't know what the frequency of data collection is, but tons of data, really. Yeah. And then that's actually then transmitted to via a little modem to the yellow surface buoy, and then that has a Iridium satellite transmitter on it that transmits the data to a satellite, which is then transmitted to a lab, and that's at Woods Hole in Massachusetts.
That's amazing. So these surface buoys, they are staying on the, based on your diagram, they're in the ice, but still they're moving with that particular piece of ice wherever that ice goes. Right. And is it multi-year ice then, or I would assume that it's targeted? Or?
Yeah, that's the idea, is you get it into some ice that's actually going to move around for a while.
This year, though, we were in pretty thin ice. It was probably just first-year ice, less than a meter thick. That's what they are settling for nowadays, because it's really hard to find multi-year ice up there.
Okay. Yeah, that was kind of my next question, is how many could you actually put out in a multi-year ice pack? That's not really there anymore.
Right.
Very fascinating. Yeah, I bet there's volumes of data there. It's amazing.
Oh, yeah. Which, by the way, is all public.
Go ahead.
It's all that data is publicly available too. The Woods Hole website hosts it, and you can look at it anytime you want. Yeah, right down there. You got it.
All right, very cool. There was a question about the polar bears. Let's see, go to those pretty bears. Well, I'm asking here. Let somebody find the polar bear picture. The question was from Astrid, did everybody get polar bear training?
What was the polar bear training?
They didn't really tell us much about that.
Okay, but you guys didn't get trained in dealing with polar bears. That person was hired to be your guard. Basically.
Yeah, he was one of the quartermasters, and that was part of his duty, was to load the rifle, and he stood off probably 100 yards from the ship, and everybody kind of, was working between him and the ship with the knowledge that you kind of looked around occasionally.
Okay. The next question was about the Sammys. It says, do you retrieve Sammys after a year? How far have they traveled after a year?
Well, that's a good question. We deploy them on those moorings, but they're in a fixed location that Dave described with the anchor and the thousands of feet of cable that go up to the surface. Those stay in place, and those are out there for a whole year. The ones that they're on the ice tethered profilers move around, and the longest duration ones we've had out there before they failed or before we don't know what happens to them, they just quit communicating, is about 200 days. And they move hundreds of kilometers during that time. Maybe over 200 days, they'd move about 500 kilometers. But they tend to go in circles because the ice pack just kind of roams around like this.
And I'm not sure, Judy, is this your question about how heavy are those? Are you asking how heavy the Sammys are?
No, that was in conjunction with a discussion about the Ctd Rosette.
Oh.
So how heavy is a CTD?
Yeah, I mean, they look very heavy.
Yeah, they're big. I don't know. They're several hundred pounds. They need a large lift and fairly stout cable, and when those things get swinging in big ocean water, it's a beast of its own. And sometimes they actually canceled some of the Rosette samplings that were scheduled because the rollers were the sea was just too big, and so they it just wasn't safe. They'll take you out.
Yeah, that's impressive for sure.
Yeah.
Another question that came up is Dave, I think this has to do with the data that you've been gathering from the cruise. How and or will you get to use any of the data that is gathered in your classes? Will your students get to use any, I should say?
Yeah, that's a mystery right now. I'm just trying to think of ways to integrate it, and I've kind of schemed on some things, but I haven't got anything really concrete that I've nailed down that I see that the one thing I'm going to try and do is incorporate the carbon dioxide and pH end of things into some of the solution chemistry that I have students or that we work with, and I got some ideas of how that's going to work, and then I've got some other ideas also about how to maybe do some a little more advanced projects that students could be involved in. But the actual data that we collected being used by students tomorrow, I kind of don't think that's going to happen. It's just there's so much of it, and how it dovetails is a little bit of a beast. So, but the experiences that I can talk about with students are fantastic, and they've got all kinds of great questions and want to know all sorts of fun stuff. So,
we have a shared summer student who's going to be working in the lab.
Oh yeah,
this winter, and he worked in my lab this past summer, and there may be another student who comes along that would be interested in working on the data. We have lots of data, and we're more than happy to have these guys get involved in it as much as they can.
So yeah, it's happening. It's a work in progress.
Yeah, well, I'm sure it will take a long time for the scientists themselves to go through all that data. All right, we have, looks like Kim's typing. So I think I went through all the questions that came up while you were doing your presentation. Oh, there you go. Kim has a question. Dave, do your students feel connected to the Arctic even though it is geographically so far away?
Probably not. they probably feel more connected now that I have, been there, and I can, show them some slides, and I've shown them some videos of ice breaking going on and things like that. But it's still, I think for high school students, it's still not something that really registers on their radar that well. It'd be really fun to take some of them up there, even if it was just on a a land-based sort of thing. But yeah, so that's how I think of it.
That's true. It would be nice if we could take them all the way there. Clap says fantastic work, great presentation.
Thanks, Jim.
Does anybody? I unmuted. I think I unmuted most everybody. So if anybody wants to actually ask a question, including I think Mary on the phone, you're sure welcome to talk now. And
yes, this is Mary Frances Jones. I'm Dave's mom. I want to know what a sundog is.
Oh, yeah, sundogs are pretty cool. Let's see, where is the sundog? There it is.
There it is. Yep,
Yeah.
you just went back.
So sundogs happen because of the ice crystals that are in the air, and so they always happen at I forget the angle, but it's this. Well, where's the pointer at?
Same angle as a rainbow.
Yeah.
54 degrees.
Yeah. So this and this over here are known as sundogs, and it occurs because of the ice crystals that are in the air, and then it's essentially a rainbow. And you don't get to see those in the lower latitudes because there's just never very much ice. We see them here in Montana every so often, but nothing like this. This was just amazing how they stood out and were just beautiful.
So multicolored, like a rainbow.
Yeah, it's definitely you can see there's kind of the red on the inside, and then it goes through the entire spectrum. So really pretty. And then somebody was saying that there's also something signature about there was a term for it. I forget what it was, but it was the fact that you can actually see the whole entire column of light that then shines across the ice. I forget Judy, do you know what that's called? Or Janet, rather?
I don't remember, and it was Tim
Yeah.
Martin. He had a term for that, so I'll look here in a moment.
Yeah. It's like the column of
Okay,
fire
thank you.
or something. Yeah, you bet.
We also saw some northern lights.
We did, yeah. I didn't put any shots of those in. I should have, but too many pictures, too little time.
Mm-hmm.
Very good. Well, you'll have to share those pictures with your mom in person there.
This is our cup that was shrank. Can you see that? So this is a styrofoam cup that when you put it on the Ctd Rosette and goes down to 4,000 meters, it gets squished. That's what they look like when they're...
Yes, I remember seeing those photographs. We're on the telephone because we don't seem to be able to get our computer to work.
Ow.
Oh, shoot.
That's all right. That's right. You'll have to have, like I said, you'll have to have your personal slideshow.
There you go.
Show you through all these things. Plus, this will be archived, so you'll get a link to the actual movie, so you can do a repeat.
Oh, good. Okay.
Yeah. Is there anybody else that has questions that's online and would like to just ask them through the mic or say something through the mic? You're more than welcome to.
Overwhelming.
Got some questions. I don't think you can.
Oh, no, okay.
That's all right.
Let's see here. Profiler.
Look at Ken Martin's question there about the sundog.
Yeah.
I'll have to find that for you. There is
a term for it, yeah.
Okay.
We didn't have polar bear training. We had helicopter training. So that was, if you're going to fly in a helicopter, you got to know what you're supposed to be doing. And I actually had a fun opportunity. One of these shots, I'll go back to it. Let's see which direction. That shot up here in the upper right is a shot I took from the chopper. And they asked me, I got lucky here. The right place at the right time, but they were like, well, we're going to take a flight and see if we can find some ice. Do you want to go? And I was like, you better believe it. So got to take it was about a half-hour flight out over the ice, and got stuffed into a submersion suit and all the appropriate gear that goes with it. And,
yeah, Dave was officially labeled a journalist on board the ship, and so every time something they thought was important came up, he had a beeper, so they would call him to tell him about what was going on.
Huh?
Yeah.
Great opportunity.
Yeah.
It is. And the light pillar is that piece in the middle when you see it from top to bottom of a sundog.
Light pillar, right. Yeah.
Light pillar.
Yeah.
Anyway, okay. It looks like a couple of people have already saying goodbye, and let's see. Let's see what Astrid says here. She's saying, were there any situations when? Go ahead, Astrid. You can just open up your mic. It might be easier than typing. Microphone's at the top of the screen, just above the image. Oh, keep typing.
When I felt uncomfortable. Well, there were a couple days where we were in some pretty heavy seas, and I never got seasick, but just constantly roaming the hallways and you're always looking for a third point of contact on some surface to keep yourself upright. So that was interesting. It was kind of fun, actually. But at one point I kind of felt a little like nauseated, so I laid down for half an hour and managed to clear it up. And then the workout situation too was hampered by that a little bit. It's pretty interesting trying to row a rowing machine in a rolling vessel.
I can visualize it.
Right. Yeah. So, but yeah, overall, I mean, I can't really think of any time that I really felt like, I don't know, maybe Mike feels differently, but it was really, really fun.
It's a comfortable ship. Having been on some really small research vessels that really move around in the waves, and you can smell diesel fumes and grease and all kinds of things that set your stomach off. This is quite luxurious, relatively speaking. Of course, they have a bar. American research vessels are dry. They don't allow any alcohol on board. So this ship had a bar which was open 2 hours a day and led to a lot of socializing.
Yeah, go ahead. Sorry.
I was going to say, so one thing that was kind of an interesting experience was being. Well, my cabin was towards the front of the bow of the ship, and it was right behind the bubbler system, which is a pretty. It's a couple of air compressors that have a really high whine. So you have this high whine, and then you're crashing through the ice, and it's kind of scraping against the side of the boat, and that goes on for 4 solid days. And it's kind of like being in a metal box car going down a train track at 50 miles an hour in a full-on hailstorm. and swaying back and forth and just kind of like, well, this is kind of an interesting experience. And it doesn't stop. It just goes and goes and goes and goes.
Yeah, the noise can be distracting.
Yeah. Yeah. So, but again, I don't think it, what does that say? No unexpected. Yeah.
No encounters.
I don't get that one.
Some from northern Scandinavia.
No unexpected encounters? Were you connected all the time?
Sort of. The internet connection was there, and it was via a satellite, and we got email, but I don't think I actually surfed or did any kind of actual internet work the whole time. I think I tried once, but kind of gave up. Encounters with animals. Well, we saw the polar bears. We actually did see. So I had 3 bird species I got to add to my list, my life list. One of them was a Ross's gull. Another one is an ivory gull, which was quite rare. And then the third was our last couple of days, we had some rock ptarmigans actually land on the ship. And this was after a couple of days of pretty heavy winds. So somehow they got blown off course. I don't know what they were doing, but they ended up on the ship. I think there ended up being about 4 of them on the ship, just kind of hanging out. And then the next day they were gone. So they were obviously resting.
We did see some whales from a distance as well.
Yeah, so.
That's pretty cool about those rock ptarmigan. I might have to report that to Bill Schmoker, my bird person.
Yeah, I've got the photos too, so.
That is pretty cool. You might get a most northern sighting right there. There's got to be something for that when those birds blow on this. All right. I think it's about time for us to wrap up if there's any other questions, and I'll just wait to see if there's anything. But in the meantime, I just wanted to say thanks to Dave and Mike for doing this, and we're glad you're back home and had time to process where you were. I know that was quite the cruise that you were on. Cruise is not quite the accurate word I want to say for those kind of trips, but people think you get like full-range buffets and you have dancing salons and things like that, but it's no such thing. You're working your tail off there, we know. Anyway, for those of you that joined us online and by phone, we really appreciate you joining us, and we'll send out a link to the archive in a couple of days. It'll be online as well as by email to everybody that registered. And so we just want to thank you all for joining us.
Well, thanks for sharing it.